Okay, guys, now that we know the relationships between the angles when we have parallel lines in a transversal, we're going to take a look at proofs and prove that angles are congruent using those properties or proving that lines are parallel. So here's a couple more properties that I want you to jot down in your notebook. So remember, anytime during the video, make sure that you pause the video if you need more time. This is the diagram that we'll be using throughout this lesson. So if you want to create that. So the transitive property simply says if A equals B and B equals C, then A must equal C. So that's the transitive property. That's going to come in handy a lot. The substitution property, if A equals B, then A may be substituted for B or conversely. Again, pause the video at any point that you need it. Let's recall our corresponding angle postulate. We use that for the first few proofs we do today. So if two parallel lines are cut by a transversal, the corresponding angles are congruent. Remember, corresponding means in the same location, like 1 and 5, 3 and 7, 2 and 6, and 4 and 8. Those are the corresponding angles. So our first example is we are given that lines L and M are parallel, and they want us to prove that 3 and 6, angle 3 and angle 6, are congruent. So let's state what is given. L is parallel to M. The reason is the given. Okay, so we can't just go into that these are congruent because of alternate interior. We have to use a few other postulates, theorems to prove this. So I do know that angle 3 and angle 2 are congruent because they are vertical. So let's say angle 3 is congruent to angle 2 because vertical, and I'm going to abbreviate, vertical angles are congruent. I could have gone several different ways to prove angle 3 and 6, but this is the direction I'm taking. Okay, now that I know 3 and 2 are congruent, I also know 2 and 6 are congruent. Oops, statement number 3. Angle 2 is congruent to angle 6 because of what we just looked at. Corresponding angles are congruent. And since 3 equals 2 and 2 is congruent to 6, we can conclude that angle 3 is indeed, that is a little messy there, sorry about that. We can conclude that angle 3 is congruent to angle 6 because of the transitive property. Okay, so that is our first proof. Okay, number 2, again, L and M are parallel, so I'm going to state that in my picture as well as in my 2-column proof. L is parallel to M because that was given to us. They want us to prove that angle 1 and 8. Again, I can't just say they are because of course alternate exterior angles. So let's do what we did similarly to the last one. I know that angle 1 and angle 4, they are congruent because they're vertical angles. So I know that 4 and 8 are congruent because of corresponding angles are congruent. And then, since 1 is congruent to 4 and 4 is congruent to 8, I can conclude that angle 1 is congruent to angle 8, and that's what we wanted to prove by the transitive property. Okay, let's look at number 3. So again, we're starting out, lines L and M are parallel. That was given to us. We are trying to prove that angles 5 and 1 are congruent. So let's see what we know. We know 1 and 4. 1 and 4 are congruent because they're vertical. So angle 1 is congruent to angle 4. And then I know angle 4 and angle 5 are congruent because we know that alternate interior angles are congruent. And so now we can apply the transitive property again. 1 is congruent to 4, 4 is congruent to 5, therefore angle 1 is indeed congruent to angle 5. So these ones are simple, and we'll get a little bit more complex. Okay, so let's write the theorem, alternate interior angles converse. So our converses is the opposite of proving that angles are congruent. It is saying if two lines are cut by a transversal and we know the interior angles are congruent, the alternate interior angles are congruent, then the lines are parallel. So if they tell us 3 and 6, these are alternate interior, are congruent, then the alternate interior angles converse says line L and line M are indeed parallel. So let's okay, the corresponding angles converse postulate. And again, we're going to use the converse postulates to prove lines are parallel. So go ahead and jot this down. If we know like 1 and 5, those are correspondings. If they tell us 1 is congruent to angle 5, then our lines L and M are indeed parallel. Okay, so what is given is angle 3 and angle 6 are congruent. So now let's take a look at what else we know. We know we can go say that 3 and 2, angles 3 and 2 are congruent because they're vertical. We know vertical angles are congruent. So what else do we know? We know that if 3 is congruent to 6 and 3 is congruent to 2, then we can say angle 6 is congruent to angle 2 because of the transitive property. So if 6 and 2 are congruent, they are corresponding angles. And if we have corresponding angles congruent, then we know that line L is parallel to line M. So this is going to be the corresponding angles converse. Okay, so we use the corresponding angles converse. So 3 and 2 are vertical, 2 and 6, or 3 and 2 are vertical, congruent, 2 and 6 are congruent. Therefore, the two lines are indeed parallel. Okay, alternate exterior angles converse. If we can prove alternate exterior angles, if we know that those are congruent, 1 and 8 or 2 and 7, then we can conclude that L and M are parallel. Okay, so we are given that angle 1 and angle 8 are congruent. That's the given. Okay, let's see what else we have. So we know that angle 8 and angle 5 are congruent. Vertical angles are congruent. If 1 is congruent to 8 and 8 is congruent to 5, I can conclude that 1 and 5 are congruent. So 1 and 5. Again, the transitive property. And if 1 and 5 are congruent, those are corresponding. And if corresponding angles are congruent, the lines indeed are parallel. And this is the corresponding angles converse. So the converse proves lines are parallel. Without the converse, the original proves that angles are congruent. Okay, number 6 says angle 2 is congruent to angle 6. So let's mark that. 2 and 6 are congruent. So we could say angle 2 and 3. Angle 2 is congruent to angle 3. Vertical angles. Whoops, dropped my little pad. Are congruent. And then our transitive property of 2 and 6 are congruent, and 2 and 3. Then we can say angle 6 is congruent to angle 3. So 6 and 3, the transitive property. And then if we know these two angles, they are alternate interior angles, alternate interior. So we can use the alternate interior angles converse to prove that L indeed is parallel to M. It's the converse.